All right, let's take a look at a question involving Lensmakers equation, maybe magnification equation, certainly a lens question. So you can pause it, read the question for yourself and see the possible answers, but I'm going to highlight the important part here. So the first thing we see is that students measured the object to be 10 centimeters tall. So the height of the object is 10 centimeters. Now, my advice to you is acknowledge and be aware of the signs for each of these things. So heights of objects are always positive. I'm not going to leave that to chance. I'm going to put the positive there. The students place the object 3.2 centimeters in front of a lens. That's a description of the distance that the object is from the lens. So DO is also always positive, and it's 3.2 centimeters. So there's two pieces of information we have. Now they observe a virtual image. I'll make a note of that. And the distance from the image to the lens, so that is DI. DI is 4.3 centimeters. And again, I'm going to acknowledge whether it's positive or negative. In this case, they say it's a virtual image, so I know virtual images are negative. So DI is negative. And in the end, we want to figure out the kind of lens, which you'll see really comes down to knowing what is the focal point. If we can figure out the focal length, then we can determine the type of lens being used. So, given that information and knowing we have to calculate the focal point, I feel like, the height of the object is interesting, but if we just want to know the focal length, we really can go straight ahead right now and use the Lensmakers equation. 1 over f is equal to 1 over di plus 1 over do. And I feel like that's enough to figure out the focal point, knowing di and do, which we have. All right. So got all our information organized. Should be straightforward to substitute in. 1 over negative 4.3 centimeters plus 1 over do, 1 over 3.2 centimeters. And we'll put that into our calculators here and find out what the answer is. So in the end, the focal point, focal length is equal to 12.5. We'll call it 13 centimeters. So looking at our, and of course that's positive. So in the end, we have a 13 centimeter. So we can eliminate A, we can eliminate C. It's either B or D. And then because the focal length is positive, positive focal point means that it has a real focal point. So we have a choice here. We have our diverging lens and we have a converging lens. And this one has a real focal point. And so in the end, I think it's a converging lens with a 13 centimeter focal point.